Hi guys, today's LEET-CODE daily problem is amount of time for binary tree to be infected, and it's a medium problem. The prerequisites of the problem are you are given a root of a binary tree with unique values, and a string start and an integer start. Start is given. The start will start at minute zero. Okay, and at minute zero, an infection starts from the node with value start as the unique as the tree as a unique value, so we can consider the start to be the node also, right? So at start node, the infection starts, and each minute a node becomes infected. If the node is currently uninfected, e- at each minute a node becomes infected. If the node is currently uninfected, yes, and the node is adjacent to an infected node, and the conditions are whenever we go to a node, the node should be uninfected and the node should be adjacent to the infected node. That is, this is the infected node. The adjacent nodes are its parent, its left, and its right. Right. The adjacent nodes of this infected nodes are the parent node, the left node, and the right node. These are the adjacent nodes, right? So the conditions for a node to be infected is it should be adjacent to the infected node and it should be uninfected currently. Okay, return the number of minutes needed for the entire tree to be infected. We need to return number of minutes such that the entire tree is infected, right? So uh, when we say the adjacent nodes are infected, we can think of a DFS problem, right? Like BFS problem, right? So breadth first search solution works here, and for getting a parent node of a current node, for getting parent node of a current node, I think we need to do a DFS here, right? So for forming a parent, for getting the parent node of current node, we need to do a DFS, and for solving the problem, we need to do PFS. So both the DFS and the BFS are used in this problem, right? So first of all, we need to get the parent of the current nodes, right? Like for example, the parent of one is null, right? And the parent of five is one, right? The parent of three is one, right? So in this way, we need to get all the parents of the all. So first of all, we get the all the adjacent nodes of a current node. Okay, so the adjacent nodes of one are its parent, which is null, and 5 and 3, right? So after coming 5, the adjacent nodes are 1 and 4, right? After for 4, 9, 2, and 5, right? So these are the adjacent nodes. We try to store in a list of map here for getting the adjacent nodes of a current node, which where key will become the current node and the list will become the adjacent nodes of the current node. Right? Set. Okay. So as for doing that problem, we took a hash map here which tells the current node comma adjacent nodes. Adjacent nodes are stored in the list. So in this way I stored them, and I solved a DFS problem, DFS recursive problem here, recursive function here, which is solved. It will form all the adjacent nodes of the current nodes. So I need to send the parameters, right? I send the root value and its parent value, which is null, right? So I've sent here, and hash map as a hash. So coming to the DFS here, and if the root equal to null, then we are at a position where there are no adjacent nodes, right? So we can just return right, which is a void function. So I am just returning here. So when I comes to a node where it is not equal to null, then I can say that there are adjacent nodes of the current node, right? So whenever uh, I reach to a node first time, then I need to set my current node list to a new array list, right? I have to initialize my array list, right? So for that, I'm using this condition here. So whenever it comes to a node which is not previously identified or returned, so I will just put the hash dot put the root dot value common new array list. I will just initialize my current node list as new array list. Okay, and next condition is if pre, that means pre is my pre is here, parent here. My pre is here parent node, right? So if at all my parent node is not equal to null, that means it has a value, right? So the parent node has its children, right? So for that, I'm getting the root dot value as a key. For that, I'm for for example, this is the node, and this is the current node where I am, and this is the parent node. For this node, I'm storing this as a parent, this as an adjacent node. See, that's it. For this node, for 5 node, I'm storing one as a adjacent node. Yeah, I'm just adding it to the list. For parent node also, I'm storing this 5 as the adjacent node here simultaneously. Okay, same thing. And I'm going to the left and right as the pre-order traversal here. So this is the map, like DFS solution here. And coming to the BFS solution, I'll be going to the uh, I'll go into particular. I will start at my start node, and I will go to the all the adjacent nodes, and at last I will end up going all the nodes, right? So in this way I can solve this problem. So I have for solving the BFS problem, I think we need a queue, right? So I took a key queue, and I have also took hash set here, which stores the integer, which tells me whether the integer is coming or not. Like I'm taking condition that it is a visited array, so visited visited array kind of thing here. Whenever it is it contains whenever the node contains, I will just continue from there because it is already visited. As the condition said, the node is currently uninfected. So as this says the if the current node is present in this list, it says that it's already infected, so go to another node, right? So we need to uh, go to the uninfected node, right? So for this I am storing a visited node here, visited list here, visited has set here. Okay, and okay, I'll start with queue. I'll just add my start to my queue, and visited also in visited array also I'll be adding this start, and I will take a parameter called result parameter, which shows how many minutes I've taken to infect a whole tree. I will perform a BFS algorithm here, which says I will q dot size and the size of q, and for every element, uh, I will take a list of this, and which list of this is like 1, 10, and 6, right? I will iterate over them, and I will check whether they are visited or not, and I will again, if they are not visited, I will just make them visited and add it to the queue. In this way, I will just do the BFS problem, and at last I will be returning -1 here. Why? Because see, for example, I am at the starting solution. For this to be considered, for this to be done, I will take 1 minute, right? After that, I will call this. I will call this. Yep. And for these, it takes 2 minutes, right? For adjacent nodes to be completed, 2 minutes, right? So, and for 5 to be completed, it takes 3 minutes, right? For 4 to be completed, it takes 4 minutes. So, as we can see here, for the BFS problem, we get 5 minutes here. So, uh, for 5 minutes here, because it goes to the nodes repeatedly, right? For repeatedly, it considers it as a plus plus plus. So it will always increase the value of the result by one. So for not uh, for considering that case, we have to just return result minus one here. So this is the LEET-CODE daily solution. The problem amount of time for binary tree to be injected here, and the space complexity and time complexity of this problem are, and time complexity is big of n here. Why? Because we are big of n means, and in the sense the number of nodes in a binary tree here. Okay, and the space complexity is big of min of minimum of n comma n. So here the space complexity is big of minimum comma n, minimum of n comma k. Oh no no no, sorry, this is n, big of n only here, because as we are taking hash map as a solution, hash map auxiliary space and the set as an auxiliary space here, right? So this is the solution for this problem.